Hey everyone, welcome back to my Calculus 1 series. In today's lesson, we'll be going over the derivatives of trigonometric functions. The derivatives of all these trigonometric functions, obviously there is a way to derive them. However, you probably won't be asked to derive all of them in Calculus 1. Like, I'd honestly be surprised if you'd be asked to derive something like that on a test. From what I know, the majority of people just kind of memorize them. And because they've worked with them for so long, they just kind of know them off by heart. So I'm going to go ahead and list them, but obviously you can look into how they are derived and stuff like that. So these are the derivatives of all the functions. Well, not all of them, but these of the main ones. There's not really much to talk about. If you want, pause the video, kind of get to know them, be familiar with them, because you're going to be using them a decent amount. But yeah, essentially most people just memorize them and kind of know them off by heart. So yeah, here they are. Pause the video, but I'm going to move on to the examples and how we can apply these to problems that we would most likely be given. So let's say we are given a function where f of x is equal to sine x times cos x, and we are asked to find the derivative of this function. And applying what we learned from last lesson about the product rule, we could see that this right here is a product of two functions. So the first one being here and the second one being here. So let's apply the formula for product rule and solve this problem. So again, this would be like f of x and this would be like g of x. I'm going to link the product rule video up above right now, so you can check that out if you don't yet know product rule. So first we want to take the derivative of f of x. So let's take the derivative of f of x, which happens to be sine x. And we're going to multiply this by just cos x, so g of x. Then we can add on the derivative of g of x, which is cos x. And then we can multiply this by sine of x, which is f of x. And again, if you haven't memorized these derivatives yet, I suggest you do, but we can always just reference back to the few that I wrote up there. So the derivative of sine x would just be cos x. And then we're going to add the derivative of cos x, which is minus sine x. And again, this is pretty easy. We can group these two, and we'll be left with a derivative of cos squared x minus sine squared x. So there you go. There's our answer. Pretty simple, but you can see how now we're using a combination of the product rule and these trigonometric derivatives. So now let's look at a function like this, and now we can notice a multitude of things. Firstly, we have a trigonometric function here, and we have an exponential function here, but on top of that we have the numerator being divided by the denominator, so we can see that we're going to apply quotient rule. So there's going to be a decent amount of stuff to recall from previous lessons, and again, I'm going to link the derivatives portion of my video so you can check that out if you haven't yet learned about it. But let's apply the the quotient rule. So if we're asked for the derivative of f of x, this would equal to, first we are going to take the derivative of the numerator, which is cotangent, and then we're going to multiply this by g of x, which in this case is here. So this would be g of x, and then this would be f of x. I keep referring them to like that as f of x and g of x because that's how I refer to them back in my product and quotient rule video, but I'm sure you get the point. And then we are going to take the derivative of the denominator, which is e to the x, and we're going to multiply this by cotangent of x. And again, let's not forget to square the denominator. So there it is. And now we are going to apply all of the derivatives that we have learned so far. So the derivative of cotangent of x is minus CSC squared x and then we still multiply this by e to the x. The derivative of e to the x is just e to the x, as we know. We're going to multiply this by cotangent of x. And all of this is going to be over ex squared, which can be simplified as e to the 2x, because it's a power in powers, so we can multiply the two powers. And I'm going to simplify this a little bit more, but we can see that on the top we can factor out both these e to the x's. So we'll be left with something like this. And now we have common factors on both the top and bottom of the function, so I'm going to go ahead and cross those out, this and this, and we will just be left with minus CSC squared x minus the cotangent of x. Oops, that was a little sloppy. And then e to the x here. So there you go, there's the derivative. And you can see now how we're starting to apply a lot more rules and kind of theorems. We've applied here the derivative of an exponential function, the derivative of a trigonometric function, and on top of that we've used the quotient rule. So yeah, from here on out the derivatives are just going to get a little more tricky, but nothing changes, we just have to remember those rules. So yeah, that's it for the derivatives of trigonometric functions. Thanks for tuning in, and I hope you enjoyed it. Like usual, if you are new to the channel, please like, comment, and subscribe. You can feel free to join my Discord channel, and yeah, I will see you guys in another video.